We're going to do 9.3, three variable systems of equations. All right, so to solve a three variable system, well, first I'm going to tell you guys that a two variable system that you guys are most familiar with, right, a two variable is a line with another line and the solution is a point. Sometimes there's no solution, sometimes it's all real numbers, but you have a point like that and we call that point x, y. With a three variable system, it's a plane with another plane. All right, so imagine like a sheet of paper, or imagine three sheets of paper, and you can kind of mix them all into one, and the point where all three sheets intersect is your point. That's kind of hard to draw, so I'm not going to draw it, but what you should know is that your answer is an ordered triple. So it's an x, y, and z coordinate. All right? The process is a little bit lengthy. It's not the hardest thing in the world, but it's definitely not the shortest thing in the world. So just pay attention, follow along. It's really not as bad as it seems as long as you're careful with your work. So to solve a three variable system, the summary is on this page, but it's easier if I just show you guys. But you're going to eliminate one of your variables to create two new equations. And with those two new equations, you're going to have a little mini system, and you're going to solve that little mini system and then plug those answers back into one of your original equations, and then you're going to get a third variable, right? It sounds a lot in words, but we'll just try it together. It's not as bad as it seems. So let's look at this one. So the first thing I like to do is number the equations. So I'm going to number it 1, 2, and 3. Right? So 1, 2, and 3. What I would do with these types of problems is I would first just quickly glance at this system, right? So we see three equations, three variables. Which letter, x, y, or z, looks like it would be the easiest to eliminate? X, right? I would say x. Some people said z just because of the second equation. What don't you see? You don't see a z, so you might think, okay, if I combine 1 and 3, that would get us that would eliminate the z, and then we don't have to do much more than that. Just keep in mind, to get a 3 and a 5 to be the same, you would have to multiply this first equation by a 5, and then this one probably by a -3, right, to get them to be the same number but opposite. You get kind of big numbers. We don't really want to deal with that. So sometimes it's best to just try to manipulate the problem the least amount as possible. Said that kind of weird, but the less you do to each of your equations, the better. It's less confusing. So I'll just show you what that would look like. I would say we can eliminate the x, right? If we combine, let's say, the first equation and the second equation. So x minus 2y plus 3z equals 9. And then the second one is negative x plus 3y. There's no z, so I'm going to leave it a little blank right there, equals -4. When we combine these, what happens to your x's? They cancel out right away, right? So there's not much we have to do to get the x's to eliminate, right? So that's why x in this case, I would say, is the easiest variable to eliminate. What happens when we do -2y plus 3y? That's just a y, right? And then 3z plus nothing is just 3z, right? And this is going to equal 9 minus 4, which is what? 5. Good. So this equation that you get right here, I'm going to call this new equation number 1. New 1. You can label it however you want, right? You can call it equation A and the other one equation B. You can call it the I and then II. Doesn't really matter how you do it. Just something so that you know that it's different from the original three equations, right? You want it to be different, or you want it to be clearly labeled differently from the first three that we originally had. So we're going to do that same process to find another equation, still eliminating the x. So we already used 1 and 2 to eliminate an x. What can we do now to eliminate another x using any other two equations? Which one? Sure, we can do 2 and 3 and multiply equation 2 by 2. So we have a negative x plus 3y with a little blank equals negative 4. And then we have a 2x minus 5y plus 5z equals 17. And then do we see that we can very easily eliminate x by multiplying this equation by 2? All right, so distribute. You're going to write a negative 2x plus 6y, there's no z, equals negative 8. And then when we combine these two equations, what eliminates? 2x minus 2x, right? That's what we want to happen. What happens when you do negative 5y plus 6y? That's just a y, right? And then 5z plus nothing. It's just 5z, right? And then what's 17 minus 8? 9. So then this is our new equation number 2. I'm going to call it new 2. All right, so we have 2 equations. We still haven't found anything, but we're going to use these 2 new equations to set up a new little mini system, and we're going to solve that little system. So do we see now in new 1 and new 2, what I labeled, what are the letters that we see? Just a y and z. Do we know how to solve a 2-variable system? Hopefully yes, right? That's all we did last week. So new 1 and new 2 are going to create this little system that we can very easily solve. So y plus 3z equals 5. And then we have a y plus 5z equals, 9. All right, what can easily eliminate in this little system? Y, right? We can multiply one of them by negative 1. And then we're going to be left with a negative y minus 3z equals negative 5. And then the y's are going to cancel out, and then this is going to get us a 2z equals 4. So then what is z? 2, right? Divide both sides by 2, and we get z equals 2. So that's one of our 3 letters. All right, are you okay with that? Good, right? A bit of a process to get there, but the more you do these, it becomes super repetitive. What can we easily find now? Y, right? If we plug that into any one of our new equations, we can very easily find y, right? I'm going to plug it into the first one. So then we get y plus 3 times 2 equals 5. So then we get y plus 6 equals 5. Subtract 6, and then we get y equals negative 1. So now we have 2 of our 3 letters. What's the only one missing? X, right? So what we can do is we can plug this into, we can plug this into any one of our 3 original equations, and then we're going to get x. Sure, we can plug it into the first one. So I'm going to plug in, wait, you can't really see that, hold on. So I'm going to plug in y and z into that first equation. So this is going to be x minus 2 times negative 1 plus 3 times 2 equals 9. So then we get x plus 2 plus 6 equals 9. So then we get x plus 8 equals 9. Subtract 8, and then we get x equals 1. All right, are we missing anything else? No, right? So this is going to be 1, comma, negative 1, comma, 2. All right, so we have an ordered triple. So remember, this is always x, y, z. All right, are you okay with that? Okay, let's try the same thing with this one. What letter, x, y, or z, looks like it would be the simplest to eliminate?
Y.
You think y?
Yeah, because the bottom 2 will have just singular y.
Z.
I would say z. If you chose to eliminate any other variable, you're going to get the exact same answer that I will, just your steps might look a little bit different. Do we see why I'm choosing z, though?
Yeah, you don't change it.
Yeah, because if you combine 2 and 3, you don't have to change the sign of anything. It's just that eliminates right away. And then all you have to do for 1 and 2 is to multiply by 6. When Esther comes back. Okay, so then let's combine. The first thing we should do is 2 and 3. You should always start with the easiest one, right? So we get 2x plus y minus z equals 2, and then we have an x plus y plus z equals 2. So 2x plus x is going to get you 3x, y plus y is 2y. Z and z cancel out. And this is going to equal 4. All right, so then this is our new equation number 1. You can call it new 1. I'm just going to call it n1. So I have n1. And that is my first equation in terms of x and y. And now what you're going to do is you're going to combine any other 2 equations to eliminate a z as well. I'll do 1 and 2. Right, so if you do 1 and 2, we have a 3x plus 9y plus 6z equals 3. And then equation 2 is 2x plus y minus z equals 2. How can I get those z's to cancel out? Good, right? Multiply the bottom one by 6. And then when you do that, we get 12x plus 6y minus 6z equals 12. And then so we can ignore this now. We don't really need that anymore. All right, and when you combine those 2 equations, what are you left with? Good, right? 15x plus 15y equals 15, right? And so this is our new equation number 2. All right, so kind of the beginning is the hardest part. But once we get that far, it shouldn't be too bad. All right, what should we do now? Yeah, right, so now we have another mini system. I'm going to do n1 with n2. And this is going to be 3x plus 2y equals 4. And then we have a 15x plus 15y equals 15. All right, what can we eliminate here? I would say x is the easiest one to eliminate. What can we do to eliminate it? Good, we can multiply the top one by -5. Similarly, you can also divide the second one by -5. All right, do you see that everything in the second one also has a factor of 5? So you could do that. You get smaller numbers, but it's not that big of a deal. So let's just keep doing it this way. So we get -15x minus 10y equals -20. And then we have the x's eliminate, so we're left with a 5y equals -5. Divide both sides by 5, and so what is y? -1. So we have y is -1. What other variable can we easily find? X, right? So we're going to plug this into one of our 2 equations. It doesn't matter which one. I'll just say the first one. And then we plug it in there, and so then we end up with a 3x plus 2 times -1 equals 4. So you get 3x minus 2 equals 4. Add 2 to both sides. What do we get for x? Good, right? 3x equals 6. Divide by 3, and then we get x equals 2. All right, so we have an x and a y. What's the only thing missing? A z. So then you're going to plug in x and y into whatever equation looks the simplest. Which one looks the simplest? Definitely the third one. Super easy to plug it in. So then we end up with a 2 minus 1 plus z equals 2. We get a 1 plus z equals 2. Minus 1 on both sides, and then we get a z equals 1. So then what is our final answer? Nice. 2, -1, -1. I'm sorry, 2, -1, 1. right, are you okay with that one? Again, a bit of a process, but hopefully by now we kind of get it, or we're kind of seeing the general steps of how to solve these. There's just 2 examples left. We can finish them today. All right, so we can try the same thing here. All right, what's the first thing we can do? All right, so we can number them, right? So 1, 2, and 3. Right, which letter, X, Y, or Z, looks the simplest to eliminate? Definitely the Y, right? We already have a positive and then 2 negatives. So let's combine 1 with 2. So we have a 2x plus y plus z equals 9. Negative x minus y plus z equals 1. And then combining these, 2x minus x is just x. The y's cancel out, and then we get x plus 2z equals 10. So this is our new equation number 1. All right, what other 2 equations look like we can combine? Okay, 1 and 3. All right, I like those just because they already have opposite signs. So we have a 2x plus y plus z equals 9. And then a 3x minus y plus z equals 9 as well. All right, so then combining these, this is going to get us a 5x. The y's cancel out. Plus 2z equals 18, and this is our new equation number 2. Okay, yeah, good question. So, yeah, when you're finding your new equations, you want the exact same variables eliminated. Just because, let's say I had a system with an x and a y, and then an x and a z equals a number equals a number. When you go to combine these, you're going to end up eliminating one of them, but you're still going to be left with a y and a z. So you want to make sure that you're ending up with something that is solvable, right? You can't really solve a 2-variable system if there's 3 of them, right? So you don't want to end up with something like that. So if there's an x and a z here, you want an x and a z here. All right. So now we set up this little mini system, n1 with n2. So this is going to be x plus 2z equals 10. And then we have a 5x plus 2z equals 18. So we have this little mini system, what looks like it's easiest to eliminate. Definitely the z, they're the same numbers, so all I'm going to do is multiply by a -1. And so we have a negative x minus 2z equals -10. Combining these, we get a 4x equals 8, so what is x? Two. All right. And then we can plug that into any one of our 2 equations. I'll just plug it into the first one. So then we get 2 plus 2z equals 10. And then we're solving for z. Guys, focus. So then we get 2z equals 8, divide by 2, and then we get z is 4. So we have x equals 2, z equals 4. What can we try to find now?
Y.
Good, we can very easily find y now. I'll plug it into whatever equation. Doesn't really matter which one. I'm going to plug it into the first one. Okay, sorry about that. Okay, so then now let's plug in the x and the z into one of our equations. So this is going to be a 2 times 2 plus y plus 4 equals 9. We get a 4 plus y plus 4 equals 9. That's going to get us a y plus 8 equals 9. And then we can subtract 8 on both sides, and so we get y is 1. All right, we found everything, so what's our final answer? 2, 1, and 4. 2, 1, 4. Again, the more of these that you do, the easier it gets. It shouldn't be extremely difficult. It might just take a little bit of time. These are definitely the more time-consuming ones. All right, but shouldn't be horrible. Okay, let's try one more. This one should be fairly quick. Let's do the same thing, 1, 2, and 3. Okay, good, right? So it looks like here the easiest thing that we can do to eliminate is 1 and 3. So then we have an x plus y minus 3z equals negative 1. So negative x plus 2y. There's no z. This is going to equal 2. So we can just combine these straight away. X's cancel out. We get 3y minus 3z equals 1. And this is our new equation number 1. All right, so we have a y and a z in this equation. Look at the equation that we didn't use, number 2. What letters do you see there? Also a y and a z. So this is a nice one. You actually don't need to find a second equation, right? Because we already have one that has just y and z. So let's just use equation 2 and our new equation number 1 to solve a little system, right? Because this already gives us 2 variables. So I have a y minus z equals 0, and then a 3y minus 3z equals 1. All right, what can we do to eliminate something here? Sure, we can do, yeah, right, so we could do by negative 3. And then we get a negative 3y plus 3z equals 0. What happens when you combine? What's 3y minus 3y? 0. What's negative 3z plus 3z? 0. So we're just left with 0 over here. What's 1 plus 0? 1. Is that a true statement? No, right? So this is no solution. All right, so then we end up with a no solution. Visually, what this would look like, it just looks like 3 planes that are never going to touch. So imagine just 3 sheets of paper. And they're not touching, just floating in space. All the other ones that we actually got a point, just picture 3 sheets of paper crossing over each other, overlapping. They intersect at just 1 point. All right, but this one intersects at no points. All right, that's it for this lesson. There's just 4 examples.